Okay guys, so this is a video to help you out with page 534. We are doing numbers 20 through 34 even. All right, we already did the odd ones, so now we're going to go through and do the even ones. But on this homework, I'm actually going to go over several questions like 20, 28, 32, and a part of 34. Anyway, let's jump to number 20. And remember, what we need to do to be able to simplify these fractions, we need multiplication. So that's why we factor anything possible. All right, let's factor anything possible. So there I jotted down the two steps that we're doing. Again, there's minus, minus, plus, minus. We cannot cancel this x squared with that x squared because of the pluses and the minuses that all of these terms have. That's why we're going to factor to be able to get multiplication and then cancel. Okay, so keep that in mind. Always factor first, and there's many possible ways of factoring. Up here we have a quadratic trinomial, ax squared plus bx plus c, where the a value is 1, and we know that factoring those, let me zoom in a bit here. Factoring those is one of the easiest things in the world. Here's my fraction. On the numerator, I put an x here and an x there, and then I simply think what times what is my c value that if I combine together is my b value. So we might want to make a list, right? What times what is negative 14? We have negative 1 times 14, negative 2 times 7, and that's it. So which pair of numbers, when you combine them, will give you a negative 5? Well, if you go 14 with a negative 1, that's 13. That's definitely not 13. We want a negative 5. So this can't be it. And over here we have negative 2 and 7. When I combine those, it gives me a 5. But I need a negative 5, so I have the right number, I just have the wrong sign. I have the right numbers, I just have the wrong signs. So go ahead and change that to a plus and that to a minus, and you're good. That's a pair of numbers that you want. Now, where do these pair of numbers go? They go in here. So let's put the positive 2 and the minus 7 right there. Now, we have factored the top. Let's look at the bottom. This is a quadratic trinomial, but it's not in standard form. It's all out of order, right? You want your x squared term first, just like up here, x squared first, then your bx term, and then your c, right? So let's rearrange this, right? Commutative property of addition and subtraction allows us to rearrange it. So let's just take this x squared, which is actually a negative x squared, and let's write it first. So we have a negative x squared. And then we have that plus 3x, and we have positive 28. So instead of this, all I did was move this last term to be in the front. Now it really is in standard form, ax squared plus bx plus c. Now, I could put a line through this since I already rewrote it. This is my new denominator. However, notice that we're used to having quadratic trinomials that have an a value of 1. That means that there's no number out here. And right here, the a value is negative 1. We don't want negative 1. We want it to be a positive 1, right? So let's do this. Let's factor out a negative sign from here, okay? Let me make more space. I'll just do it right here. So let's factor out a negative 1. That way, on the inside, we will have a positive x squared with a minus 3x with a minus 28, okay? So now we could look at this black quadratic trinomial and factor that the way we normally would. And of course, this is in the denominator. So we have x right here, x right there, and we need to think what times what is negative 28, that if you combine together is negative 3. So if you would like, go ahead and make a list. What times what is negative 28? Well, we have a negative 1 times 28. We have negative 2 times 14. Negative 3 doesn't work. Negative 4 times 7 is 28. Negative 5 doesn't work. Negative 6 doesn't work. That's it. Those are all the possible ways, 3 possible ways of multiplying numbers together to give you negative 28. Of course, besides changing the negative sign, right? But let's take a look and see, if I combine these two, will it give me a negative 3? Of course not. That gives you a 27. So that's definitely not it. 14 take away 2, that's 12. And the middle value is not 12. We want it to be a negative 3, so that's definitely not it. And over here, we have a -4 and a 7. If I combine those, that'll give me a +3. And we know we want the middle value to be a -3. So we have the right numbers, we just have the wrong signs. So go ahead and put a +4 and a -7, and that's the pair of numbers that belong right in there. So let's put the +4 right here, the -7 right there. And again, what have we done so far? We have factored everything possible, and now let's cancel. Step 2, cancel. So do we have any identical terms in the numerator and in the denominator? Well, we have an x plus 2 up here, the binomial x plus 2, but there's no x plus 2's down here, so we can't cancel that. We do have an x minus 7 and an x minus 7, and that is absolutely all that you could do. So your final answer for number 20 is x plus 2 over x plus 4. Yeah, it had parentheses, but in reality, we do not need them anymore. There's nothing else to do. Can't cancel the x's because of the plus sign. So I hope number 20 makes sense, all right? That's your answer right there. Now, if they asked you what value would make this undefined, then you would say x cannot be -4. As a matter of fact, you could even go up here to the factored form of the original before canceling, and you would say what values would make it undefined? A +7 would make it undefined, and a -4 would make it undefined. So you could, if you wanted to, say, but x cannot be -4 or +7. But in reality, our answers, they don't even have this part. So all I really care about is this right here. But just so you could know, just in case in a future test or something, those values that make it undefined, you would say that x cannot be those values. And you would go to this up here, because 4 would make this a 0, which would make the whole thing undefined. A -4, I'm sorry. -4 would make it a 0, which would make the whole thing undefined. And a +7 would make it a 0, which would make the whole thing undefined. So again, on this homework assignment, if you check the solutions, you don't have this part, okay? Just this part. All right, let's move on to another question, number 28. Now, I saw some of us struggling on yesterday's assignment on the odd ones. This is something very basic. This is from Algebra 1, guys. We need to remember that when you have a fraction divided by a fraction, the division of that fraction is really the same thing as multiplying by the reciprocal of this fraction. And a reciprocal would simply be taking the numerator and the denominator and flipping it. So change that to multiplication and flip this fraction. So the first fraction is going to stay identical, 9x squared y is z over 5z to the 4th. The second fraction, change the multiplication. The 50 will be on top. You have an x y to the 4th up on top with the z squared up on top over the 12 x to the 4th y to the 2nd. So now that we have pure multiplication, right? There's no addition, no subtraction anywhere. This is 9 times x squared times y times z, right? They're all pure multiplication. When you do have that multiplication, you cancel everything out, right? The steps up here, factor first. Well, there's nothing to factor. These are all monomials, and there's no addition. The whole purpose of factoring is if you did have a plus sign, then you could get that multiplication by factoring. Okay, but this is all pure pure multiplication. It's ready to cancel things out. So you could cancel out one of these z's up here. This single z up here, you could cancel it out with one of these 4 z's that are on the bottom. So one z up there completely disappears with one of these 4, and you will have 3 left over. Okay. Not only could you cancel from up here and down here, but you could cancel from down here and up here, right? As long as it's with the numerator and the denominator, you could cancel. So for example, when I look at that 50 up here, the 50 over 5, that's really 50 divided by 5. Or the fraction 50 over 5, which reduces down or divides to the answer 10. So 50 divided by 5 is 10, so you have a big giant 10 up there. 5 divided by 5 is 1, cancels out, no more 5 on the bottom, okay? How about the x's? Actually, let's stick with the z's. I still have 3 z's down here. This one completely disappeared. Right here, I still have 3 z's down here, and up here there's 2 of them. So I want to make these 2 z's completely cancel out with 2 of these 3's, leaving me with only 1 left. So I want to take the two z's up here completely cancel them out, put a line through both, and it'll cancel with two of these threes, leaving me just one z left on the bottom. Let's go for x's now. Well, x's, I do have x squared up here. That's two x's. That will completely cancel out with two of these four. So I'll have two left over. And then I have this one single x up here that'll completely cancel out with one of those two. So that canceled out. So I only have one x left on the bottom. Okay. What else could we cancel? We've done z's, we've done x's. Let's go for y's. As you could see, I have one y up here and two y's down there. So I could cancel one. This one y is going to completely cancel with one of these two. So now I just have one y left on the bottom. But I do have four y's up on top and one y on the bottom. So this one y on the bottom will cancel with one of these four up here. So that's what I'm going to do. That y on the bottom is going to completely cancel with one of the four, and I will have three left over up there. I know this is ridiculously messy, but I hope we're understanding how to cancel, okay? So what do we have left? On this first fraction, there's a 9 up on top. You know what? We could even cancel further before I jump to the actual rewriting of fractions. This 9 up here and this 12 down here, 9 over 12, you could reduce by 3. 9 twelfths could reduce by 3. Or you could say 10 twelfths. You could reduce 10 twelfths by 2. So it's totally up to you. Let's reduce the 9 over 12. How's that? 9 divided by 3 is 3, and 12 divided by 3 is 4. So I reduced 9 twelfths by 3, giving me 3 fourths as an answer. And last but not least, let's reduce the 10 up here with the 4 down here. 10 over 4 you could reduce by 2, and you'll have 5 over 2. So now let's finally rewrite our two fractions. Let's see what we have left. We have a 3 up on top. We have a single z on the bottom. We have a 5y to the third up there. And down here we have a 2x. Now we are multiplying fractions, and we can multiply the top with the top and the bottom with the bottom. This is after completely canceling everything out. So 3 times 5y to the third is 15y to the third. Z times 2x, that'll be a 2xz. So there's your answer for number 28. Could have this been done differently? Absolutely. There's many ways you could have done this differently. Instead of canceling first, you could have multiplied the top with the top, gotten an answer, the bottom with the bottom, gotten an answer, and then canceled everything out, right? So I hope this makes sense. Let's say that you got too confused with canceling. You could, let me actually demonstrate how you could multiply first. So as you could see, I just rewrote what I had right here. All I did was flip that second fraction. There it is. There's my whole original problem. I could have, from the beginning, multiplied 9 times 50 and gotten 450. I could have multiplied the x squared times the x, give me a x to the third. Y times y to the fourth, give me a y to the fifth. Z times z squared, give me a z to the third. And then on the bottom, I could have multiplied the 5 times 12, which is 60. Z to the fourth times x to the fourth times y to the second. Let's just put them all in order. X to the fourth, y to the second, z to the fourth. And then from there, I could have simplified this guy by canceling things out. So you could have multiplied and canceled as opposed to canceling first, then multiplying. It's totally up to you. Let's see how this goes. Well, the 450 over 60, you could immediately cancel out the zeros, making it a 45 over a 6. And if you reduce 45 by 3 and reduce 6 by 3, you'll get the 15 over 2 that you have up here on the original, or on the answer the first time we did it. Okay. So again, 45 divided by 3 is 15. 6 divided by 3 is 2. And then you could cancel out the x to the third. All three cancel with 3 of these. You'll have 1x left on the bottom. The y squared on the bottom, there's 2 y's on the bottom. Both completely cancel out with 2 of these. There'll be 3 left up on top. And the z to the third on the top will completely cancel with 3 of these 4, which means there's 1 z left on the bottom. There's your final answer. I don't know. Actually, this seemed easier, right? Multiplying first and then canceling. It's totally up to you, though. I'm just showing you the different ways you could do these problems. It's up to you to decide what's most comfortable for you. Do you want to cancel first and then multiply, or do you want to multiply first and then cancel? Either way, you'll get the right answer. Let's jump to the next example that I want to do. Number 32. Again, we want to factor first and then cancel, right? So let's look at each numerator, each denominator, see if we could factor anything, okay? So on this top one, this is a quadratic trinomial where the a value is 1. So it's very likely that when I rewrite my fraction, I'll be able to do the c and the c and then think what times what is my c value, that if I combine together is my b value. And if you need to, go ahead and make a list. How could you get negative 16? Well, you could go negative 1 times 16, negative 2 times 8, negative 3 doesn't work, negative 4 times 4. That's all the possible ways of getting negative 16 besides changing the sign, the negative sign. So which pair of numbers combines together to give us this middle value, the b value of negative 6? Well, if I combine negative 2 with 8, that'll give me a positive 6, but I want a negative 6, so I have the right numbers, I just have the wrong signs. So that should be a positive 2 and a negative 8. So you can put a positive 2 right here and a negative 8 right there. So we have factored this above quadratic trinomial that had the a value of 1. Now some of us will freak out right here. C squared minus d squared. What times what is d squared that if I combine together is nothing, putting the c, like that gets confusing. But the fact is, this is a difference of 2 squares, a difference of 2 squares. It's very similar to this one, x squared minus 9. X squared minus 9, this is a perfect squared term, that's a perfect squared term. When you have perfect squared terms, you should be able to set up your factored form format and just simply think, what's the square root of x squared? Oh, that's x. What's the square root of 9? Oh, that's 3. And because there's a minus sign right here, then you would just repeat that x and 3, and you would just put 1 plus and 1 minus. That would cause that last value to become a negative 9, and it would cause the middle terms when you distribute to cancel out, okay? That's the difference of 2 squares, 2 perfect square values. X squared is a perfect square term. 9 is a perfect square term because 3 times 3 is 9. So when I look at this guy right here, I need to use that difference of 2 squares knowledge to be able to factor it to the square root of c squared, that's just c, put it on both, and the square root of d squared, that's just d, put it on both. And of course, one has to be plus, one has to be minus in order for you to actually get a negative d squared and in order for the middle value to cancel out. So we've factored both of those. Now, the second fraction, it does say to divide, which means we need to change that to multiplication, and we need to flip the second fraction, all right? So my second fraction is going to be flipped, and of course I can't factor c plus d. There's nothing to factor there, so I'm just going to rewrite it, but up on top, c plus d. Now on the bottom, I should have a c squared minus 8c, but I might as well factor it so I could rewrite it down here in the factored form. So if you're thinking, well, what times what is a c value? Wait a minute, there is no c value. Yeah, of course. What's the first method that you should try factoring by? The very first method you should try factoring is to pull out a GCF. That's the first method that you learned. It's the first method that you should always try. So you should try to pull out a GCF. So what is in common in both terms? There's obviously a c in both terms. So we're going to take that c and pull it out of both terms. We're going to take the c and pull it out. So we're going to have a c out here in the front. And what would be left on the inside? Well, if you pull out a c from here, you'll have one single c. If you pull out a c from the minus 8c, you'll just have a minus 8. And there we go. We've factored everything. Now we just need to cancel things out because now we do have pure multiplication. If you guys could see, there's a numerator up here that says C plus D, and there's that same identical C plus D down there. So this guy up here and that guy down there will cancel out. The binomials completely disappear. How about the C minus 8 that we have up here and the binomial C minus 8 that we have down here? Let's just cancel those out. Gone, right? Is there anything else that could cancel? The answer is no. We have a C plus 2, and this is not a C plus 2. If you're thinking, well, I could cancel that C with that C, no, you can't, because there's a plus 2 and there's a minus D. It has to be the entire binomial. You have to have multiplication in order for you to cancel, okay? So this is our answer. Let me rewrite it. Our answer would be C plus 2 up on top, no more parentheses, you don't need it. On the bottom, you do need the parentheses around the C minus D. Why? Because we have this other C that we need to multiply it by. So you either put that C out there or actually distribute it through, but I would just leave that C out there with the multiplication sign right there in front of the parentheses C minus D. So there's your answer for number 32. I just wanted to explain number 32 because a lot of people might freak out right here and forget about the difference of two squares. By the way, that's Algebra 1 stuff. We should all know this. Let's move on to the last one. I'm not going to do the whole thing. I just want to show you a part of it. So I know a lot of people on number 34 are going to freak out because they're going to see this a value of 3. And it does take, I mean, if you're seeing the a value of 3 and you're thinking, oh, I need to do that long process of factoring, you know, where you go a times c, you get an answer, think of the multiples of that answer, and then you rewrite it in factor. Like, it's a long process. However, again, let me repeat this. What is the first type of factoring that you learned? Factoring out the GCF. So always start with trying to factor out the GCF. So on number 34, I'm not going to do the whole thing. I just want to make sure that you guys don't get stuck with this guy. All you have to do is pull out a 3, and you will have an a squared plus 2a plus 1 left over. And that's your real numerator with the 3 on the outside. And now this could be factored further to a parenthesis parenthesis a plus 1 times parenthesis a plus 1. But you guys could handle that on your own, I'm pretty sure. So let me rewrite the whole thing. And over here, change to multiplication and flip them, right? You're going to have an a squared minus 4 up on top and a 12a squared minus 12. So you could handle the rest. This, you're going to be able to think what times what is a negative 10, that if you add together is a negative 3. Right here, you're going to think what times what is 1, that if you add together is 2. Don't forget about the 3 on the outside, though. Keep it on the outside. Right here, what times what is negative 4, that if you combine together is nothing because there's no middle value. Right here, pull out the GCF of 12. So I hope this long video helps, and I hope we're all able to do all the homework I've assigned so far.